Hey everyone, and welcome to our Module 6 lectures. This week we're talking about Chapter 7, which discusses the development of manipulative skills. So the primary manipulative skills we're discussing from the chapter are reaching and grasping tasks, which will make up Part 1 of our lectures. And then the second part will be focusing on catching and anticipation. And that's the content that will be a little bit more relevant to helping you completing your activity for this week. In terms of grasping and reaching, these are usually movements that occur as a unit. So the relative timing between reaching for an object, opening your grip or configuring your hand to the shape of an object, and then finally constricting the fingers around that object to grasp it usually are fairly similar from task to task. So while there are relative timing patterns that are fairly consistent between these two things, sometimes it's also nice to look at them separately to kind of better understand how our developmental changes end up making sense. So we'll start off with grasping. And during infancy, we refer to grasping as prehension, which is simply the grasping of an object with one or two hands. The developmental progression of grasping was first defined in 1931 by Halverson. And what he did is he filmed infants between the ages of 4 to 13 months old and had them perform a task with a 1-inch cube, and notice there was a general transition from what are called power grips to precision grips. Hold on a second. There they go. Okay. So we kind of discussed or hinted at what power grips are last week in our ballistic skills, specifically for striking patterns, but usually power grips are going to be distinguished from precision grips by the use of an opposable thumb, which makes humans kind of distinct from other species in the world. So power grips are going to be characterized by more of squeezing objects against the palm, while precision grips are going to be using the thumb and one or more fingers to grasp an object. So the relative timing of when precision grips start to show up on average was about 9 months, but as early as 7. So this these 10 stages of grasping represent the sequential changes that we can expect based on changing individual constraints and neuromotor maturation. But we know from this class that it's not just that simple, and things aren't just affected by individual constraints alone. So research that kind of followed Halverson's initial study ended up showing that the shape and the size of objects influence the type of grip that's used, but also the study by Newell in 1989 and his and colleagues found that precision grips were observed at ages earlier than 9 months when the task constraints were modified. So actually changing the object characteristics allowed for observation of precision grips earlier than what was previously suggested. Also noticed in this study is that there were generally kind of like 5 types of grips that were dependent on the shape and size of the object, and we have some examples of what those grip types would have been on the right here in this image. There was another study in 1989 done by Newell and colleagues that looked at older ages. So these first two, this Holstein study was almost an exact replication of the Halverson study, but with changing task constraints such as the shape and the size of the object. The Newell study looked at 4 to 8 month old infants, and then this other study by Newell and colleagues looked at older children and adults to look at what the differences were in grasping characteristics. And what they ended up noticing is that there were similar grip patterns used by both children and adults when objects are scaled to hand size. So if you gave an adult a larger object compared to a child with a smaller object, Relative to their hand size, they had fairly similar grip patterns, and this relates back to this concept of body scaling. Okay, so if you recall from our Module 2 lecture, we discussed that body scaling is basically how the function or affordances of various objects change based on how the object characteristics align with individual constraints. So in grasping movements, the hand size would adjust to match the object size based on how the person views the affordance of that particular object. So here we have a certain grip configuration to hold a glass, which is different than the grip configuration we would use to pick up a coin. Body scaling also helps us to choose if we're going to use one or two hands based on the shape and weight of the object. So something smaller like this coin maybe is better achieved by using a unimanual task versus picking up a heavy stack of books, which might be better achieved using two hands or a bimanual task. So in order to body scale objects, we have to appropriately process visual information, because clearly here, what we see or how we perceive the object in our environment is going to influence how we interact with it. So I thought this was just comical because it's some Marvel humor. But vision, or the role of vision, is used mainly in the preparation stages of the grasp. So an individual will gather information about the object size, shape, etc., and then sometimes they might actually be able to estimate the weight of the object based on the material it's made out of. If you think like looking at a plastic block versus a glass one, you kind of get a sense based on those differences in materials how heavy you would expect the object to be. So sometimes we can estimate that characteristic, but visual information also relates the position of the hand or hands to the position of the object in space, so we can kind of estimate when we will come in contact with it. And we can also track the time of that point of contact based on how fast the object is moving in space, how fast we are moving in space, or kind of both. So you could be moving to a stationary object, an object could be moving to a stationary you, or a combination of the two. Research-wise, I'm going to botch this name, but Bushbeck et al. I apologize to whoever this is. In 1998, they did a study on 6 to 7-year-olds, and what they found was that there was greater visual dependency in comparison to adults, and in accurately shaping the hand to match the size of the object. Additionally, there was a study by Pride and colleagues who noticed that 9 to 10-year-olds slowed down their movement at the end stages of reaching more than adults. So both of these findings are identifying some age differences, and they both suggest that there's some type of continual processing of visual feedback occurring when we do some type of grasping tasks, and that visual feedback is important for successful completion of the reaching and grasping. I know right now we're kind of talking more about grasping, but again, both of these things do happen usually as a unit. So the reach occurs kind of like 75% of the movement unit, and then the actual grasping kind of occurs at the last 25%. So the age differences also point out another important factor to consider, and that is that there are a lot of structural changes that occur early in childhood. Right? We have differences in hand size and arm length, overall body size. There's a big growth period from infancy up until kind of like pre-adolescent stages, or kind of later childhood, and then pre-adolescence through adolescence. There's another large growth period. We kind of touch on this in later chapters, but if your structural constraints are changing at a very fast rate, that means that children have to recalibrate the visual control of their movement kind of based on those changing structural constraints. So, considering grasping, that would apply to the control of, say, grip aperture or hand configuration. Grip aperture is just saying like how wide the hand is spread out. So there aren't really many changes in grasping motion with age per se, unless someone kind of develops like arthritis or they have a hand injury that changes their fine motor control. But a greater number of constraints influence the reaching component of the grasping reaching unit. So now we can kind of shift our focus onto the development of reaching throughout the lifespan.